Hello. Yeah, so we come to this question, grade 10 electric circuits. And the question says, consider the circuit below. So this is the circuit we are talking about. Okay. We are having a resistor here. We don't know it, but probably we will not need its value. We are having this R1 and R2. We're having this one unknown, but at least we know the V across. So that's the circuit we are considering now. And the question says, calculate the voltmeter reading V. So this is what they want. How do we go about that? So when you analyze this circuit, this is what you have to know. We know the terminal voltage, V terminal. And we know the voltage across here. This is one of the first component. We know the we don't know this one, but at least we know it's V. We know the voltage across here. And that one gives us a view of what equation we are supposed to use. Okay, we know that for parallel components, Vt of V terminal is equal to V1 plus V2 plus V3 plus, depending on the number of resistors you have. But for this case, you have 1 set, 2 and 3, so we can as well stop here. Now, we know the V terminal. It is given as 12. And if we take this one to be our V1, we know it is 4 volts. For this one, we don't know it, so we can as well put it as V. But for this one, we know it as 6. So all the 3 sets of resistors have been represented here. And what do? We calculate. We simplify. In simplifying, we have 12 equals to, I'm collecting like terms here, giving us 10 plus V. That gives our V to be equals to 12 minus 10, giving you 2 volts. So then comes this question. It says that what is the PT or potential difference across R1? Okay, we have just calculated V and we found it to be 2. Now, to answer this question, you need to know that parallel components have the same voltage or have the same PD. So the PD across R1 is 2 volts. And it's the same PD across R2. Why? They are in parallel. Yes. So then comes this question. It says, what is the ammeter reading A1? This happens to be our A1. So to determine the reading, you have to make follow-up of the current. Okay, let's start from here. Current flows here. It doesn't go through the voltmeter. It passes through. Here it's registered as 3 ampere. So it's the 3 ampere which passes through the battery. And it is the 3 ampere which passes through A1. So the current registered by A1 is 3 ampere. Okay, then we come to number 2. Current registered by A2. That's the ammeter reading. A2, we are seeing it there. So to determine A2, we have to make a follow-up. We said it is 3 ampere, which passes through the battery and passes through A1 and passes through this resistor and comes here. Remember, no current passes through the voltmeter, so it passes here. So the current reaching this spot is 3 ampere. But now we are seeing something here. When it reaches here, it divides. Part of it goes up and part of it goes down. So in other words, it separates. So we are having I total equals to I1 plus I2. If we happen to call this one to be I1 and this one to be called I2. So what does that mean? That means that I total, which we know is 3. I1, we don't know it. But I2 is 2. So that's what we get. From here, we can categorically say that our I1 is 3 minus 2, giving you 1 ampere. So I1 is 1 ampere. So we proceed to this one, voltmeter reading V2. Okay, so we proceed to this one, voltmeter reading V1. Okay, our V1 is the one across the parallel network. And we found it already. We saw that the PD across the parallel network is 2 volts. Here we have to know that the reading of V1 is the same as the reading of V. So the answer is 2 volts. Yeah. Then comes this question. Says, draw the circuit above this circuit and show the direction of electric current in the circuit. Okay. How do we go about that? Okay, we have the circuit here. And all I need to tell you is that this long stroke is positive and this side is negative. And conventionally, I have to tell you that that's a wrong direction, but it was adopted. Conventionally, electric current flows from positive. So we take this one and comes down. We need to know that no electric current passes through the voltmeter, ideally, because the voltmeter has infinite resistance. So our current will proceed. It comes here. When it reaches here, what happens? It divides. Part goes there and part comes here. And here and here. We have to know that no current passes through the voltmeters because of the same reason. They have infinite resistance. So here, it combines to proceed. And here, it goes up Remember, it doesn't pass through the voltmeter for the reason we know. Then we proceed here, and it comes back. That's the trace of the flow of current in this circuit.